Today I'm going to be showing how to set up LizardFS, and before we set up anything and try to dump commands into a Linux terminal, I think you should understand how the full system works. And so let's take a look at it. So it's designed to be a distributed file system, which means there's multiple physical systems that make one logical file system that you can read and access to. And LizardFS is what basically manages this. So we're going to go say, these are all computers, and they're all going to have 2 hard drives each. They can be whatever size. It's very good at managing multiple sizes. And hardware-wise, it really doesn't matter. They're basically working as basic file servers. Fairly low bandwidth, fairly low IOPS. With hard drives, if you're doing SSDs, you're going to need more IOPS. And then we're going to need a few more things to manage it. We're going to put another server here. And this guy is going to be called the master. And the master's job is, its goal is to manage which data goes where and to do what. So then we're going to have a client. Now, LizardFS has a client that runs natively on most Linux distros, and I think you can get it on OS X pretty easily using Fuse. But it's primarily Linux. They have a Windows one, but you have to pay for it. The lazy way is to make a Linux system host a share. And you can combine the master with one of these systems here. The systems that actually hold your data are called chunk servers, because it splits all the data into little chunks. So when you take a file, it splits it off into chunks here. And then these chunks get distributed onto all the different systems. And there's different ways of distributing it. So as before we get back into it, it can either have one chunk on one system. So take your chunk and just put it on whichever system has the most free space or happens to be the most free. Normally does it based off free space percentages. You can have a mirror where it puts it on 2 of them, or you can have a parity. There's different types of parity where it will put it on one and then it will have a parity on the other. And the basic one is XOR. So you can have like a 2 XOR, which means it'll take a file, it'll split it into 2 files and then have a third parity. Or you can have it so it splits it into 3 with parity, or you can have EC, or I think the official name is error correction. And you can have, for example, 5 data and then 4 parity, which generally offer better protection and better efficiency compared to mirroring. You can have up to like as many mirrors as you want. Generally 3 is about as high as I go, because otherwise you're spending a lot of disk space. And you can still have all the failure points. But its goal is to remove failure points. For a normal home setup, you're going to have a single master. But you can add a second one as a backup here if you want. Or you can have even more backup masters and stuff if you want. And these are called meta loggers, because how MFS works, it has a metadata that it always maintains that basically tells it where all the data needs to be, so that when the client needs to access it, it goes there. So let's look at a bit how you do it. So let's say you want to do a read. So you want to read, let's say, this file here. And you're going to say, hey master, where does this file happen to be? And the master will say, oh, it has a chunk on this guy, a chunk on this guy, and a chunk on this guy. And then basically, these servers send the data back. So the data doesn't ever go through the master. The master just tells you where the data is. And then you get the data back. That's how a read works. A write works, you say, hey, I want to write this file. And let's say it's 20 gigs, or however big it wants to be. It says, oh, the max chunk size, I think, is 64 megs. It says this chunk will go here, this chunk will go here, this chunk will go here. It then writes the data, and then it confirms the write. So that's basically how it works, sending data. So it always talks to the master whenever you want to read or write, so be aware of that. Other things to be aware of. This is mostly single-threaded, but then again, it's not very CPU-intensive for a normal home user. The other thing, there's a CGI server that has a nice, pretty website. I'm going to show it because it shows you where all your chunks are and which servers, which ones have errors. If a hard drive has errors, it'll tell you the drives. Generally, you can just show these drives here. And you can either run these on RAID on the internal system, so it shows up as one drive, or you can run it as individual. Totally depends. It's smart enough so that it'll have a mirror on every server. It'll never have a mirror on the same server. So you don't have to worry about, oh, if you lose one, you're fine. You can lose these at any moment. It will not stop as long as you have a mirror or a parity configuration. If you have a single, yeah, you'll lose data. It'll tell you which data you can delete it. It has a built-in trash can, so if you delete something, it stays there for a day before it actually dumps the data during downtime. And that's most of what you need to know. There's a few more advanced features, but for a home user, you don't need to worry about that. Generally, how I do it is I run the master on a VM, because I have a big VM server I like running it on. You can run these guys in VMs if you want. Often if I pass to a RAID card or make its own chunk server, because I'm not running a ton of systems, you can scale these up. When it comes to scaling drives, you can add whatever size of drive you want. You could have like 5, 10 terabyte drives and add 20 gig hard drive. It manages the chunks between them very well. The big downsides, I'd say, is generally performance isn't great from what I've seen. You want to have at least gigabit networking, preferably 10 gigabit. I have never tried this with like a large install because I don't have the hardware to do it. But I'm assuming something would scale quite a bit better if you're running off something like Gluster or Ceph than this. This seems to be a lot more of archival storage. I was using it once a little bit for virtual machines. It is horrible for virtual machines. It is extremely slow. Do not use this for virtual machines. There's not much else to know. It's a fairly easy to set up. I'd say it's one of the easiest distributed setups. It's great for home use when you want to have more storage than one system can provide, because you can just keep adding them as well in the future, and it'll automatically keep all your data balanced. So you don't have to worry about having 2 ones in a mirror and adding a third one and you can't have any more data because these 2 are full. No, it'll just nudge data over. When it comes to OS, I personally do set up on CentOS 7 because that's what I like, but you can run whatever OS you want. I found an issue once with Debian. That's why I'm also running CentOS 2 with the master not being able to connect to it. I don't know why. It's probably something I could have fixed. But we're going to go and just run CentOS for now. So let's go through the biggest and most complicated, I'd say, part of the procedure. So this is the CentOS 7 installer here. It's been the same. It's distro from 2014. There's a lot of data here that you can configure, and I like how they do it in installer because it's all on one page. Set up your time zone to wherever you are. Time is just nice to have correct. Keyboard, by default English, that's what I speak. By default it will do a minimal install. You can have it set up with things. It also depends on exactly which image you're using. This is the full image, so it will do all the files. You can do network for updates as you go, but there you go. I have a 66 gig hard drive. There's a few ways you can configure it. I'm going to do automatic. I'm going to do manual just for a little bit. You can see I already have an install here. And we're going to delete all the files from it. So there's a few options. LVM, BTRFS. I'm not going to use it because I don't want to run cow on cow, copy on write, because I'm running ZFS below this. So LVM is nice. Also lets you very easily expand it by just making the drive bigger or even adding a second one to the virtual machine. So I can click here to add it automatically. And make a separate /home partition by default. I'm going to delete that and just make this guy bigger. I'm just going to delete both of these, and then we're going to make a single slash partition, and by having no desired size, it'll just make it the biggest possible. The reason I'm doing that is because it doesn't store anything in home. It's all stored in /var, so there's no reason to have a separate home partition here. Having this like a separate /tmp or /var can be useful, but I really don't run into this problem here. And the metadata files, unless you're dealing with massive amounts of storage, does not cause an issue. Network and hostname. This is one thing you want to make sure you get right. So turn on your network. It won't do it by default here. Your hostname by default is MFS master. You can set it to whatever you want. If you want to have multiple of them on your network, but by default it'll do MFS master. And this makes everything nice here. So, and then for IPv4, so I've already gone in my own IP address thing and given it 192.168.175. The thing with MFS master is everything here wants to use DNS. So you just make sure DNS is happy. And the lazy way to do that is on all your systems, set MFS master to the IP of the system. That's another reason why you want to have a static IP here, is because it will do that. DNS servers, I'm going to just set it to what my router is at 254. You can set it to whatever you want, but realistically DNS will not make a big difference here because this guy's never going to touch the external network except for updates. And make sure it's showing everything correctly here and say you're done. And then you can say begin install, set whatever username and password you want. Security is nice, I guess. And then it's going to be installed and we'll meet you back into the command line. Also with CentOS 7, SSH server is enabled by default, so once this is done, you can just leave it and go SSH username or password at the IP address here. So let's go through the process here. So one thing that I like to do on my systems is I like to just make it so I don't have to type in password of sudo. It's not the most secure thing to do, but it saves me time, especially when doing things like this. Next thing I'm going to do is sudo yum install-y. We're going to put tmux on here. Let's put htop, atop, inload, and other just common system monitoring tools that I like to use, and utilities that just make it nicer to use. The other thing is CentOS 7 has pretty darn limited repos, so it's going to complain not much of this is available. So you have to type in EPL to release to install these. Something like Fedora or Debian has most of this stuff already installed, and then this command will work fine. It's going to go fetch it, and now it's going to go and download all the repo info, and then install the packages. The next thing that I want to do to make this a bit better is I'm going to just do sudo yum update -y. You should probably run this on all the systems. It's going to update all the packages. It's always a good idea to do this. So let's go look at setting this up. So I've already rebooted it, and now I'm back in. And now we could see the terminal here. A few other things I like to do. Sudo system control disable firewall D. They have instructions on the site of how to use it with a firewall and which ports it's using. But that's effort. And I'm lazy here. For most home users, it really won't make a big difference. Also, test ping MFS master. This should give you your IP. But it's a bogus IP. That's bad. So we're going to do sudo vim /etc/hosts and realize that we don't have vim installed. And while we're installing vim, let's take a look at installing it. So here's the thing. Go to LizardFS's website, lizardfs.com, or just Google it. Download and install LizardFS. Go to the site. They're going to give you a repo to install. Depending on your distro, we are running CentOS 7 or Red Hat Enterprise Linux 7. Same thing, essentially. And then we can just paste this in. It'll install it. Gotta run it as root. Realize you have to do sudo-s here to run the whole thing as root. Can't just use normal sudo. And then we're going to exit from root user, and we can do yum update. And now it's going to go update everything, and it's going to go fetch to new repos. So now that all the new repos are set, we get to go and install LizardFS. So I'm going to do sudo yum install -y lizardfs-master, and then lizardfs-cgi serve. This is the web interface server. This is the master. Basically, in order to do it, you need a client, a master, and a chunk server. Chunk server is going to be on another system here than this one, but this one's going to be doing master and CGI server. And it's going to take a second or two to install it. Okay, let's go back to setting up that. So I'm going to do sudo vim /etc/hosts. You want to make sure that when you ping MFS master, it goes to the right port. Preferably, you should probably do this on all the systems you're using. This is its IP, and we're just going to call it MFS master. So now if I do ping MFS master, it gets its own IP. That's what you want to be seeing. Okay, next thing we want to change directory to /var/lib/mfs. This is where the metadata file is stored. This tells you where all the chunks are and which data the chunks have. You want to do a cp metadata-that to metadata.mfs. Just get rid of empty. I normally suggest keeping the old one just in case something weird happens and you lose it and you want to reset it. Otherwise you can do a reinstall, but that's easy. Next thing, cd/etc/mfs. This is what most of your files are called. Why is everything MFS, not LizardFS? Because LizardFS is a branch, and they haven't really changed too much. We have a lot of .dst files. These don't do anything. You gotta set them up to mfsmaster.config. You're gonna want pretty much all of these here. So we're gonna do a cp mfs exports to mfs exports.cfg. Gotta run this all as sudo, and then sudo vim mfs exports.config. And this by default will let everybody read and write all the data, and allows everyone to also read and write all the metadata if you want to do a force delete or a few other things. We're not setting up security stuff now. I might do that in a more advanced video later. Do an ls again. Next thing, we're going to edit the mfs goals. So we're going to do sudo cp mfs goals to mfs goals.cfg. Same thing, sudo vim mfs goals. Most of these are set pretty well. Basically, you have 5 different configurations and each of them is just a number of copies. Basically, they tell you some reasonable info here. There's a lot more and more later on, but basically it means you can set for things like specific data centers. Each one of these underscores means one copy on a different server. You can do XORs, so it has on different hard drives and SSDs. You can set some pretty cool stuff. By default, we're just doing different copies. ls, and then we're gonna do cp mfs master to mfs master.config, and then I'm gonna do sudo vim mfs master.config. This is the default one, so we're gonna change this so personality is master, so it knows it's master. You can change admin password. By default it's nothing. Working user mfs, this is who's editing files. You want to make sure that's just the username. That's the group name. This is the messages. By default, just it'll tell it all the things. These are pretty much set by default, all the ones you can get rid of. You could change them if you want, but that works fine. And then we're going to do MFS topology, so sudo to MFS topology.config, and then we're going to edit this guy. So this manages which IPs can do what. You don't really need to use it for a basic setup. So, and then we're going to do sudo system control start LizardFS master. It should start right up, and it's running right now. Next thing we're going to do is a sudo system control start LizardFS dash chunk CGI server. CGI CRV is how you spell it. Okay, so now it's going to be running that, and then what you should do is you should run an enable on here. So that means it'll start at boot up. So let's go look at setting up a chunk server. So I already have one connected to the system, so let's set up a second one. So first thing is setting up for the file system. And well, any POSIX file system on Linux should work. So ext4, XFS, BTFS, ZFS, I think NTFS would work, but I'm not completely sure. They suggest XFS or ZFS. XFS works great for single drives. So here's how I'm going to do it. We're going to do sudo gdisk/dev/ we're going to do SDB now. And we're going to do that. And then it's going to make a new one. And then, no, don't want to write it now. We want a new partition. It's going to take up the whole space. And then we're going to write it to the disk. And then now we want to do this for the rest of the drives. But we're just going to do SDB1 now. So then we're going to do sudo mkdir/mmt /disk1. The actual mount locations don't really matter, but we're going to just do disk1. And then for good measure, we'll do all the way through 6, because I have 6 drives in this system. You can have as many drives as you want, and there's kind of two mentalities. You either set up something like a RAID 5 here and share that as one big chunk server, or you show all the individual disks. I'm going to do individual disks now. Let's LizardFS manage it. And well, SDB, we're going to mount it at disk 2. We could just do mount. You don't really want to do that. So what preferably you want to do is here you want to run sudo blkid, and that's going to list all the UUIDs of your drive, and you see SDB1 here. And then we're going to do sudo mkfs.xfs/dev/sdb1. Forgot to do that. And then what we're going to do permanent mounting, we're going to do sudo vim/etc/fstab. And we don't have vim installed. Sudo, we're just going to use nano. You can use whatever text editor you want. I'm personally a vim person. So the way this works is you do you can do either the position, which you shouldn't do, or you should be doing UUIDs. So this is the UUID. We're going to copy, and then we're going to paste it here. And then we're going to give it the mount point. So we're going to do /mmt/disk2. You're going to use disk1 for something else here. XFS. You can use defaults, but we're not. Then we're going to give you this example here for chunk servers and that. And you don't have to follow their example, but it's suggested and it'll work fine. So we're going to just paste that in, and then we're going to do 0, 0. And then command X, Y, enter. So now if we run sudo mount -a, we can see that it ran into an issue. So those mount options actually had an issue with me, so I removed some that had issues. If your OS has issues, gotta remove them. I don't know exactly which distro they made it for, but now if I go into df-h, I could see MMT disk 2 shows up. So now we want to go and add the LizardFS ones. So we're going to just go installing LizardFS here again. And then since I'm running Debian, which is a CentOS based distro, or it's a RPM distro, I want to just copy and paste this. You do need to do it as sudo dash. You need to run it as root. Can't run it as sudo due to how the exact command works. I keep using shift accidentally because it's shift control C for the command line and just copy paste here. But now I can now go just DNF update, and now I'm ready to use the LizardFS packages. So now, nothing else. The system's been all the way updated. It's just fully updated Fedora 27. So now, or 28 actually now. So now I can go sudo DNF install LizardFS-chunk server. So this is going to take a second, and it's going to install the chunk server. So now that the drives are set up and mounted, and we have the packages installed, we're going to have to set up a few more text files. So we're going to run sudo vim/etc/hosts. It is going to edit the host file. So now if I run ping mfs master, I get some random IP. You can set this on your local DNS server if you want, or the tried and true method that's a little bit lazy and is just to set it in hosts file. You can also set it for the exact chunk server file. That works though. Next thing is you want to do sudo you're going to run sudo vim/etc/mfs/mfs chunk server. Actually though, you want to cd/etc/mfs. Just go to the directory, and then we're going to do a copy mfs chunk server to mfs chunk server.config. We don't want we're going to make a copy of the original files just in case we screw something up and we want to go back. That's generally a good idea for Linux stuff. So now we're going to do some configuration. So vim mfs chunk server. So this is the configuration for the chunk server, and it tells it what user to run at, what group. These are all default options, and it tells it what port it's using. The lazy way is to turn off the firewall, but it will tell you exactly which ports. It's normally 9420, 9422. The amount of space it should always leave on every hard drive. So if you want to share the drive with something else, give it more space, or if your drive needs more, for example, like an SSD. So there's a few options here. Default's generally fine. Sudo vim mfs htd is which drives you want. So if we look on here and we look at lsblk, we can see we did mount disk 2. So we're gonna do exit. So we're gonna do /mmt /disk 2, and this is gonna add it. So there's a few more options. The main option is to put this in front of it, which means remove it. There's a lot more advanced options for different groups. So let's say later on I want to remove this drive. I put this here, and then when it has downtime, it'll copy the data off, so I can remove the drive without ever having a file with reduced redundancy. But I don't want to add that. I'm just going to remove it. So now we're going to do sudo system control stop file OLD. I might do a more advanced video where I go over firewall configuration, but for a normal home config, as I've said before, you don't really have to worry about it if your home network's secure. So now we're going to do sudo system control start LizardFS chunk server. So now the chunk server is running. So now if we go over here and look at this, we should see it showing up. Well, there's actually one other error we had that I forgot about. So we have to do cd/mmt. And then it's going to say damaged. It's going to say, whoa, it can't use any of the space because it's damaged. So what the problem is now is we want to do a sudo change owner -r mfs and then start for every single directory and /mmt, and then we want to do restarting the chunk server. And this, once done, will allow it to have it no errors. So now we can see those 1.8 terabytes. There's a little bit used in just the override, and it'll show us all the disks on it. Show us all the different servers. It'll show us in the charts, for example, things like this is a server here, so how much data is being sent over time, info, how much data needs to move to what chunks. So now let's go copy some files to it. So now we're going to start copying some files to it for good measure. So for testing, we can see for copying files that the number of chunks is going to slowly go up, and the amount of file system objects is going to go up, and we can see total number of chunks, endangered chunks. So now, because of that, we can do cd/mnt/LizardFS. This is on a different server that has it mounted. And then we can do mfs. So you can set goal by using LizardFS set goal, as in recursive for R, and then the goal number you want, whatever custom goal you want, and then the directory. So I set the goal for this. So now that you see it, I can see on a monitoring page that there's 100 endangered. Endangered means there's only one copy. And then it's moving to the 2 valid copies here. If I reload it, you see more of them are moving, and it's slowly copying them over. And soon enough, it'll be there. And as I can see on the network status for the server I just set up, the chunk server, that it's gonna be copying and moving data around pretty consistently. So I hope this little video helps you set up your LizardFS system and start your intro into distributed file systems. I think this works pretty well with people who have a mismatch of drives and computers, and is a great way to just kind of start hoarding tons of data.